Hello, hello. We are live. We are ready to go. Welcome to the very first, from what I assume, Kubefirst live stream. We have John and Jared here, so we'll get through this. If you're watching it now, feel free to put any comments or questions in the chat wherever you're watching in from. You can also reach out to us on Slack. We'll be sharing that link at the end, but here's a quick link at the bottom here to get into the Kubefirst Slack. But without further ado, here we go. So I'm Kelly. I run DevRel at KubeShop, which is an open source accelerator for Kubernetes and cloud native and observability tools for developers, DevOps, Kubernetes administrators, all the above, that are all open source. And today we're talking about our recent acquisition and kind of partnership with Kubefirst, which is an instant GitOps infrastructure and application delivery system, ecosystem, all of the above. And we have Jared here and John here, which are the co-founders of Kubefirst, along with a couple of other engineers who are not present, but very much present on Slack. So we'll be talking about their kind of just an overall overview of what Kubefirst is, how it kind of fits into the Kubernetes ecosystem, and we'll be sharing a little bit about the latest release that just came out, in addition to the new CLI. So Jared will run through how to download everything, get it all running up through the CLI. We won't be doing the whole entire process, but we'll be showing you how to get it ready and going, and then we'll discuss what is coming up next for Kubefirst in the next releases. So, John, all you.
Thank you so much, Kelly. It's great to be here today. A good idea to start, since it's probably an introduction of Kubefirst to a lot of you. Just wanted to break down some of the Kubefirst principles. It's a very wide platform with a lot of pieces, so good to just kind of put it all on the table as to what it is that we're trying to accomplish. So Kubefirst is an open source, gitops-driven, kubernetes-centric infrastructure and application delivery ecosystem. That is a mouthful. Really what we're trying to convey to you is that it's a very Kubernetes-oriented infrastructure as code and application management system for the tools that run in Kubernetes that you depend on, for your microservices in Kubernetes, and everything that we have is infrastructure as code. So the principles that we abide by are, we want easy platform provisioning. Platform provisioning in Kubernetes is notoriously complex. There's a ton of interdependencies. And we want that process to be a much lower barrier of entry to get to the point where you have a infrastructure management and application delivery platform. We want to be leveraging the most popular tools, but our tool set that we choose for the Kubefirst platform might not have some of your favorite tools. We want to be sure that we're always accessible to all of your favorite tools as well. We do that by leveraging GitOps everywhere possible. Our architecture is very GitOps-centric. We happen to use Argo CD as our GitOps engine, but GitOps as a philosophy allows for extensibility in a really easy way. So we're excited about the angle that we're taking. We want to establish a good security posture. We want auditability throughout the ecosystem, so that at any point, any engineer on your project can know everything that changed in every environment, who approved it, when it happened, whether it was successful or not, etc. And we will not lock you in. I know there's a lot of tools in the market that are kind of sneaky about the ways that they add their hooks into your environment. We built this platform for the cloud native engineer. We built this platform for open source. We will not be the type of platform that locks you in and keeps you handcuffed to us, or any of the tools that we've selected. So this is a picture of the Kubefirst open source platform. As you can see, we're at the center, we're very Argo CD centric. We happen to provision today with self-hosted GitLab, and as a result, we're leveraging GitLab runners for continuous integration. However, we don't use GitLab CI natively. We use Argo workflows for our CI for container builds and Helm chart publishes and GitOps delivery patterns to dev stage and prod. Those are all managed by Argo workflows. We support Helm and Docker that are driven from those GitLab repositories. All of our infrastructure as code on the platform today is managed in Terraform, and the change management of that infrastructure as code is handled by Atlantis, which provides a really good auditability of infrastructure change as it occurs. It's all kind of managed in the pull request. We'll show you what that looks like a little bit later on. We have that Atlantis is responsible for all our AWS cloud resources, as well as our user management of our different teams and our Kubernetes infrastructure as well. We have a sample application. It's a little Node.js application called Metaphor. Metaphor is a microservice example that leverages our CI, that hooks into Vault for secrets management, that takes advantage of Ingress Nginx for ingress into the cluster. It takes advantage of Cert Manager for automatic certificate provisioning and renewal, and also takes advantage of external DNS for automated DNS management. So just by kind of inspecting what we're doing with Metaphor, you have an opportunity to sort of see how the Kubefirst platform is going to work for your applications. The Kubefirst goals that we have. We would like to be helping engineers with, there's a lot of complex technologies that our platform provides some really good patterns for. Kubernetes, GitOps, Argo, Vault, Terraform infrastructure as code are all rather complex undertakings. And it can be kind of hard to really see the right way to manage these complex technologies in a professional shop. And the Kubefirst platform provides a really good starting point for any organization on all of these somewhat complex technologies. So right out of the box, when you do a Kubefirst install, you're going to see exactly how to not just have infrastructure as code that manages your infra, but how to have that automated and what the patterns look like to get that automated and hooked into your pull requests and things like that. We also want to deliver a frictionless and secure infrastructure as management platform with a single command. We think that that is so important to have a frictionless delivery paradigm so that we can get out of the business of treating our clusters as pets. We need to be treating our clusters as cattle so that we can be provisioning new Kubernetes clusters with all your favorite tools, no matter how complex it is to set those tools up. We want to be able to destroy them and replace them effortlessly. We want all of our open source GitOps applications to be deliverable in a frictionless way as well. We're going to be leveraging popular open source CNCF tools that are attractive to cloud native talent. We found that a lot of smaller organizations that are looking at Kubernetes, they sometimes will pick not so popular CNCF tools. And as a result, they aren't able to attract the talent that they need to run their infrastructure. We spend a lot of time looking at the CNCF surveys, making sure that the technologies that we're picking are the best technologies according to the community, so that the choices that you're buying into with the Kubefirst platform have the longevity that you need in terms of the staffing that you're going to have to manage the infrastructure. And we're looking to build a community of users that are using these great cloud native tools basically the same way. And by doing so, we're hoping that we're going to be able to build an ecosystem where, even if you're just the only cloud engineer at your startup or one of a couple cloud engineers, We want you to have the support of everybody else that's using all these same tools the same way. So we're definitely looking for you to join our community. With all that said, let's get into the fun stuff. We have our Kubefirst 1.8 release that we just dropped last week is really exciting provisioning methodology for us. For those of you that have been following us for the last couple of years, we had a project called Nebulous. Nebulous was a container-based provisioning implementation. It was what it was. It wasn't quite the professional polish that we wanted on our platform installer. So with 1.8, we're really excited to be introducing our new Kubefirst CLI. Now, in order to have a Kubefirst platform, you need a couple things. We have a couple prerequisites. First, you need an AWS account. That AWS account has to have billing enabled. In terms of cost, there is going to be some cost associated with the infrastructure that you're provisioning. It costs about $10 a day to run the Kubefirst platform. And obviously you can scale that up and down as you please. So your costs will fluctuate as you add more and more nodes to the cluster, but you do need an AWS account and you need to have billing enabled. The second thing that you need in that AWS account is you need an active hosted zone in Route 53. And by active, what we mean is that you'll be creating a new hosted zone. When you create a new hosted zone, it's going to create some NS records, some name server records, and those records need to be added to your domain registrar. So if you get your domains from, GoDaddy or Google Domains or wherever, you'll have to add those NS records to your domain in order to activate that Route 53. We have a test in the init process to make sure that you wired it up correctly, but that is something that you'll have to do before installing Kubefirst. The third thing that you'll need is a local connection to AWS. This is using just native AWS connectivity. So if you have the AWS CLI on your local host and you can run a AWS command, get S3 buckets or whatever, then that's all that you need in order to have the connectivity that you need for provisioning. And you also need the Kubefirst CLI, which Jared's going to walk us through in a couple moments here. When you run a Kubefirst cluster create, it's going to create a handful of cloud resources, and it's also going to create a bunch of Kubernetes resources. So as far as the cloud resources are concerned, all these cloud resources are managed in Terraform and controlled via Atlantis workflows by the time the provisioning process is complete. It's going to create a new VPC to house your subnets and your EKS cluster. It's going to create an EKS cluster itself. It creates a DynamoDB backend for Vault to store its secrets in, as well as a KMS encryption key in order to keep all those secrets encrypted at rest. It'll have S3 buckets for state storage and artifacts. It will include service account roles for IAM for all the different Kubernetes services that we have that need to interact with the cloud. And there will be an ECR registry made available for container storage of your microservice applications.
John, before you finish up, we have a question already that was from the previous slide, and I think it was from Naveen Kumar, which is from QA Insights. Can you use any other public clouds other than AWS?
That's a great question. So today on the 1.8 release, we only support the AWS cloud. However, and we'll talk about our roadmap at the end of this demo, but we are looking actively to support the GCP cloud as well. So the next release that we're doing, just to sort of set that stage a little bit, today we have two known limitations. We only support self-hosted GitLab. We would really like to also support GitHub. That's going to be our next release. And we today only support AWS. in 2 releases, we're going to be supporting GCP as well.
Cool.
And there will be, multi-cluster, multi-cloud stories that follow down the road, but we're focusing on AWS and GCP initially. Appreciate that question.
Cool. Thanks, Naveen.
So the Kubernetes resources that Kubefirst will provision as part of the Kubefirst cluster create command includes Argo CD, which is our GitOps engine that we use for all of our Kubernetes magic. We have Argo Workflows, which is a Kubernetes native CI tool. Now, we happen to use GitLab runners to invoke those Argo workflows. If you were a GitHub shop, you could use GitHub Actions to invoke those Argo workflows. But we use Argo workflows as our Kubernetes native CI ecosystem, and we're looking forward to building out a really expansive list of workflow functions to make available to the community for all the common tasks that have to happen in a GitOps-oriented ecosystem. We'll have GitLab Server that runs in the cluster. That's a change from 1.7 and before. Historically, we have run GitLab Omnibus on a virtual machine in EC2. As of 1.8, we have moved GitLab into Kubernetes. It's taking advantage of our Ingress controllers and our cert manager, and everything's wired up with all the integrations that we want. We're continuing to support OIDC with GitLab as an OIDC provider, and we have that OIDC propagated throughout all the applications and the Kubefirst platform. We have Vault as our exclusive secrets manager. There's not a single secret on the platform that isn't managed in Vault. So we have Vault integrations to Terraform. We have Vault integrations to Kubernetes itself. Really good secrets management story there. External DNS cert manager, external secrets operator. Those are all pretty common in typical Kubernetes setups. Atlantis, a lot of shops don't have yet. Atlantis is our application that we use to manage the workflow of Terraform changes, and we'll include that in our demo momentarily. We'll have application delivery GitOps workflows to provide continuous integration for your microservices. Pretty easy to follow the Metaphor sample application to see how to propagate that to your microservice application so that you can be delivering to development, staging, production environment in no time also. User management with RBAC controls throughout and single sign-on. That is leveraging, like I said, GitLab as a OIDC provider, and we have that hooked into Argo CD, Argo Workflows, GitLab itself, and HashiCorp Vault as well. So you're getting single sign-on day one. And Metaphor sample application to demo how all the pieces work together. So at that point, I think it's time to see the CLI in action. We're going to throw the screen over to my buddy Jared here.
Yeah. Jared, you ready?
All right. Yeah, let's go for it.
All right.
All right. So to install the Kubefirst CLI, we're going to go over to Kubefirst, docs.kubefirst.com. All of our documentation can be found over here. The install docs. If you scroll down just a touch under the diagrams that John was just walking through, you get to our install here. You can install the Kubefirst CLI using Brew. So I'll drop into my terminal over here and install it real quick. And it's showing that I already have it installed, but that's okay. We'll run a quick help command to see what we have available to us. So now that we have the CLI, there's only 2 other commands that we need to run to get up and running. Kubefirst init, which has a little bit more description here, but the long story short is we need an email address. We don't use that, but the Let's Encrypt certificates do need to be able to send emails when those are going to expire. As we mentioned, we only support the AWS cloud. We will be supporting GCP cloud shortly, but it just in a couple releases. We have a default cluster name that we will go ahead and use, and the hosted zone that we're going to have wired up in our account. Just to call out, if this is the first time you're running the init command, this init check might take a little bit longer than you'd like. It's just a DNS propagation thing. We have to create a record to make sure that we know that the hosted zone is going to successfully work. So let's go ahead and run an init. And we'll just use some of these presets here. So you can see I have my email address, the AWS cloud, a hosted zone name of kubernetes.com, using the West 2 region, and I'm going to use a cluster name of Kubefirst. So while this is, go ahead, Kelly, I'm sorry.
Oh, look at it. It's so awesome. It looks great.
Oh.
The CLI looks awesome.
Thank you. So you can see there's a few things happening. You're always welcome to jump into the GitHub repository and go through the code if you're interested in kind of more of what's going on there. But the main thing that has just happened is we now have a directory in your home called K1. We've taken the liberty of taking a few of our open source repositories. If you go to our GitHub, the GitOps template would be one of those repositories, and the metaphor template is the other repository. All we've done in this process is take those values that you've provided to us on this with the CLI as command line flags, and we go ahead and hydrate and detemplatize some of these values that we know are going to be needed for your stack. So now that a good example of that would be if we go to the, I got to go to the other repository, the GitOps template repository. You can see here that we have all of these token values that we would need to get rid of when we go to provision. So if I go look at that same GitOps repository and the local K1 with the README, and apologize for the squishiness of that there, you can see that these have all been detokenized with that Kubernetes domain that I passed in. The next thing to do to get a Kubefirst management cluster is to run kubefirst cluster create. And this process is going to take somewhere in the 20 to 25 minute range. That's primarily provisioning an EKS cluster. So there's not a whole lot we can do on that timing, but to save you from having to watch my terminal for the next 20 minutes, we're going to kick it over to John. We have a stack that was already provisioned using the same exact process.
Cool. And how long was it before this release? Was it 40 minutes, something like that?
Yeah, before this release, when we were using the container-based installation, we were somewhere in the ballpark of about 40 minutes to see everything that we are provisioning.
Great. All right. Is this good, John?
Yeah, thank you, Jared. Great walkthrough of the CLI there. So this right here is a screenshot that's been doctored up a little bit so that I can keep my my secrets behind the curtain. But at the conclusion of the command that Jared just run, you would be presented with a screen that looked just like this screen here. And let me sign out of my browser here so that you can sort of see the experience. So what this is telling you is that we've provisioned some new software for you, and it's available at these particular URLs. We give you initial usernames to log in and initial passwords to log in with those admins. So I'm going to go ahead and sign in with the root password that was provided to me right here. And when you drop into GitLab for the first time, if you go to menu projects and then hit explore projects, what you'll find is that there's two repositories that have been created on your behalf. The first one is the GitOps repository. Now, this repository here is a hydrated version of the GitOps template repository that Jared was showing us a moment ago. But you can see the DNS that I used for my hosted zone is yourcompany.io. So you can see that you end up with a gitlab.yourcompany.io, a vault.argocd.argo. etc. All of these values are being hydrated as part of the init process, and during provisioning, you get all this infrastructure, including hydrated hosted zone that maps all of your DNS records to your Kubernetes applications. And that's how the Kubefirst provisioning process works. So in the GitOps repo, we have a couple things that we want to take a look at. First is the registry. The registry is the most important part of a GitOps ecosystem. And if we were to take a look for a moment, let me go full screen here. Let's go to Argo CD. And again, in order to get into Argo CD, you'll see here in the output from the Kubefirst installation, we give you a username of admin, and we provide you a password to use to log in here. So you'll put those values right there and sign in. There's a GitLab button up there, but you don't want to try and log in with GitLab until after you've created your team, and we'll walk through that process in just a moment. So going back to full screen. So if you type in here registry, this is a visual representation of this GitOps content. So we have laid down a series of sync waves of applications that deliver in a very methodical way. We have to create the applications that are at the core of Kubernetes, and then we have to lay a Git source on top of that, and then we have to add secrets management on top of that, and then we have to go back and apply secrets management to all the applications that we provisioned. It's a complex process to get all the applications laid out, but the end result is that you have this very, very simple directory that has all your applications that are running in your cluster. And you can inspect any one of those applications in Argo CD. And just to sort of take a look at a couple examples. So let's look at GitLab itself first. This is our GitLab server. GitLab itself has, GitLab is a complex application. It has a ton of microservices, and it can be a little difficult to manage or to even appreciate all of the Kubernetes objects that are being delivered when you Helm install some of these complex applications. But with Argo CD, it gives you this great representation of all the different services that are included as part of that installation, your deployments and the downstream pods from those deployments, your stateful sets, your ingresses, everything about the installation, all the way down to if you were to go to the GitLab web server itself, to the pod. This is the actual physical pod that's running the container, and you can see the logs that are coming from that pod. It's got Argo CD is just an incredible offering. So that's how we manage all of our applications in Kubefirst, is by managing the content in here. Now, some of these applications, like say Chart Museum, for example, is just a, that's actually not the best example. Let's look at Ingress Nginx. So Ingress Nginx is a simple application. It's just a Helm repository. And you can see that we're directly pointing to the Helm repository for Ingress Nginx directly, and we're able to put our Helm values YAML directly in line in that Ingress Nginx in the registry itself. Now, other applications can be a little bit more complex than that. Sometimes they need to be able to source secrets from Vault. Sometimes it's not just a single application, but a suite of applications that you want to manage as an app of apps. And so for content like that, if we look at development as an example of an app of apps, what you'll find is that instead of it being a Helm chart, its definition is to point back to the same GitLab repository, but it's saying to look at the components development directory to find that source. So let's go to that components directory. In fact, let me open up the go to a different view here. It's a little easier to look at if you look at the web IDE. So here we were just looking at the registry with the development YAML, and it was saying to go to components development. So let's go to components development here. And here you can see that we just have a single YAML file. So this is saying, in order to find my content, go to metaphor here. So when we go to metaphor here, you can see that this wants to drive into the metaphor chart, which defines the version of metaphor that we want in the development environment, and any values YAML overrides that are specific to our development environment. We get that dedicated space to be able to specify that values YAML just as a YAML file directly in the repository here. So that's kind of how the registry process works. to get content into Kubernetes. If you had, some application that, maybe you like all the applications that Kubefirst is providing for you, but you also really like New Relic, or you also really like Jenkins X, or whatever it might be. You can add that to your version of the Kubefirst platform by simply adding a YAML file to the registry, telling it what its definition needs to be. You can point it to a directory if you have a bunch of stuff you want to install, or if it's just a simple Helm install, you can do the Helm installation inline right in the registry object, like I was showing you a second ago. So that's the first thing that we wanted to cover, was the registry in the GitOps repo. The second thing that's important to inspect in the GitOps repository is the Terraform directory. The Terraform directory is all of our infrastructure as code. It includes, and here, let me go back to the web IDE. So it includes, base is the directory that we use for bootstrapping, basically. So all of the infrastructure that we have to create in order to have enough space for a Kubernetes cluster and Dynamo and all of that stuff, that's all in base. Now, if you wanted to add more Terraform, more cloud resources, you have to make a decision as to whether or not it should be a bootstrapped resource, or if you want it to be on its own, in its own entry point. What I mean by that is we have this Atlantis YAML file here. This defines the directories that our Atlantis will react to in order to run Terraform plans and applies. So whenever we make a change to any .tf file in, say, the base directory here, that's going to prompt Atlantis to run a plan on our behalf. Now, when you do a brand new Kubefirst cluster create execution, we leave some of the stuff that's in infrastructure as code to you to implement for the first time. So let's go through that process together. What we're going to do is in main.tf, I'm just going to go ahead and add a white space to that file there. And basically all I'm doing is making any changes to Terraform files. And whenever a Terraform file is adjusted that's in one of those directories that we told Atlantis to look at, it's going to kick off a Terraform plan, tell you anything that would change as a result of that plan, and apply it for you. So when I commit this, we'll do it to a new branch called demo time. And that pull request, or merge request in GitLab, is going to, you can see a pipeline has just kicked off, and Atlantis has woken up, and we already have a pull request open. I'm sorry about that. So what this is telling you is that there's already a plan open, and there's a locking mechanism in Atlantis, because if you have two people running Terraform against the same infrastructure at the same time, really bad things can happen. So Atlantis takes care of making sure that only one person has control of a particular plan for an entry point at a time. Now, in a circumstance like this, we have a decision to make. We either need to tell the other person that owns that other pull request to close their pull request and unlock their plan, or we could unlock the plan on their behalf. Now, this plan here is the same exact pull request. So we wanted to show you that there is a locking mechanism in Atlantis, but this same pull request, if you look at the changes included in this pull request, it's also just the 4 white spaces that I made in the other PR. So we'll stay on this pull request here. Let's look at what Atlantis provides us. So it tells us that there have been changes in Terraform base, Terraform GitLab, users, and Vault. And you can see that there's no changes in this entry point, this entry point. This one does have changes, though. Let's take a look at that together. So we have Terraform users is saying, hey, if I run this plan, I'm going to create a new GitLab group called admins, a new GitLab group called developer, and it's also going to create a whole bunch of individual users for some fictitious users named admin1, admin2, developer1, developer2. And what this is showing you is that your user management managed in Terraform can be applied on your first GitOps pull request. So what you would want to do if this was your instance is you would want to go to that repository, to the Terraform users admin folder here. And instead of allowing it to be a couple fictitious people named admin1 and admin2, this is your opportunity to take these little snippets of code and expand them to your entire team. So you can lay down all of the administrators that you want in your infrastructure. And similarly, we have a developers TF file here. You could add all of your developers that have a slightly reduced set of RBAC in the cluster. They can't do all the same things. They can still do enough to be good developers in Kubernetes, but not quite enough to be able to destroy the destroy the cluster. So in your first pull request, if you just include all of the usernames, you want to change the module names, the usernames, give them a good first name, last name, and a good email. All of those users that you add on that initial pull request are going to get new passwords. They're going to get set up in OIDC that'll propagate them to have the correct levels of access to Argo CD, to Argo workflows, to HashiCorp Vault, and to GitLab itself. Now, for the purpose of this demo and expedience here, I'm just going to go ahead and stick with admin1 and admin2 and developer1 and developer2. The wrong one. Actually, let me open that and close that guy so it stops tripping me up. And on merge request 1, which is the one we were just looking at, I'm going to go ahead with admin1 and admin2, developer1, developer2 as the resources that we're going to add. Some of the other resources in here, not to belabor the point, but it includes like getting them into GitLab, into the correct groups and stuff like that. That's why, although there's only 4 people, there's 18 resources. That's just sort of the way Terraform works. And then there's also some changes that are being made here in Vault, where we're adding a Vault JWT off backend and backend role so that Kubernetes can have access to Vault permanently for the purposes of your secret management access. So in order to apply this plan, all you have to do, whenever you want to plan or replan, the command that you type just as a comment here in the merge request is Atlantis plan, but we already got a good plan, so I'm going to change, and I like the plan, so I'm going to change it to Atlantis apply. And when I Atlantis apply here, it's going to take these changes that we were looking at. It's going to go through entry point by entry point, make sure that there's no lock against it, make sure nothing has changed to the infrastructure since that plan was produced. And as long as all of that is true, it's going to apply the changes. If the apply is successful, it'll automatically merge the pull request. It'll automatically close the branch out, and you'll get that nice audit that some infrastructure change happened right there in the pull request. Now, if the Terraform apply were to fail for any reason, and any of you that are familiar with Terraform knows that sometimes you'll get a plan and the plan looks healthy and you'll run the apply and something goes wrong because of a collision on a resource name or something like that. If that ever happens to you, it leaves the pull request open and you get to keep working on that branch until you're at a point where the plan is able to successfully apply. And then once you get a successful Atlantis apply command to complete, that's when it closes the pull request. So if it's an open pull request, that means it didn't go successfully. If it's closed, that means it did go successfully. So really nice workflow management. I really like that element of Atlantis. You know, if you've got a team that is running Terraform from your local hosts, you guys are probably all too familiar with the workflow where a cloud engineer is, running some Terraform and it doesn't go well, and they're just like hacking on their local host, and nobody can see what they're doing to get out of the jam. With Atlantis, you get a full audit stream of every single time that a Terraform apply tries to happen. So it's a really good security posture from a auditability standpoint. And that's everything that I wanted to show about. Let's take a look. It should be done by now. Yeah, down at the bottom here. So after I ran the Atlantis apply, it reports back that it did run the apply for 4 projects. It shows the results of those applies, automatically merges because all the applies were successful. It unlocks the plans, so now people can continue to make changes against those entry points where before they were blocked and it said, hey, you're not allowed to do this. Somebody already has a lock on these entry points. So really good workflow there. And let's move into the Metaphor repository. That's the other repository that you get when you install Kubefirst. This is our sample application repository, and I'm going to start out before I start describing anything about the Metaphor repository and show you what happens when any file changes in the main branch. We'll change this 2 to a 3 here, hit commit. Now I'm committing directly to main. Typically, you would want to open a pull request. I'm doing that for expedience of the demo here. But just by changing anything in the main branch, we have this sample application set up to automatically kick off a delivery workflow, a GitOps delivery workflow of the Metaphor application. It'll go through a publish operation that publishes the container and then publishes a Helm chart, and then goes through a series of GitOps delivery workflows where we deliver that, where we set the desired state of that Helm chart in the development, staging, and production namespaces. And that's our promotion process. And we'll walk through that in just a second here. Before we get into the GitOps workflows, though, it's important to understand how the GitLab and Argo relationship works. So in GitLab, if you have, they have this special file convention of .gitlabci.yaml. And if you have one of these files in your repository, then you can set up stages that represent the stages that we were just looking at on this pipeline here. See how we have the stages of publish, develop, staging, release. Those are displayed because of the stages that we have here and the conditions under which we'll run those stages. So for example, we have a lint job, but the lint job only runs on branches, and I didn't create a branch for that one. I published directly to the main branch. So this job didn't kick off. The build process is also a branch-oriented stage. Publish, on the other hand, which is what happens when you merge a pull request to the main branch, it makes a commit against main, and because of that, it's going to kick off publish and then development, staging, and production. Now, if we look at these, the CI that we run under these circumstances, you'll see an echo command. You can sort of tell that we're just writing a bash shell. However, we're not actually doing any Docker builds or Helm publishes. We're just calling these Argo submit commands. Now, the Argo submit is pointing to Argo publish YAML. So if I go to Argo publish YAML, this is how the orchestration works to get GitLab and Argo workflows to interoperate really well. So we have this is a Argo workflow. Argo workflow is a Kubernetes native CI tool. It works a lot like GitHub Actions or a lot of the more modern CI tools that have a really strong contract for inputs and outputs. It'll be a very familiar syntax to you using Argo workflows. Our Argo workflows, you can see that what we're doing is we're referencing all these template reps. The Kubefirst platform comes with a suite of common CI tasks that you can just take advantage of. So we have some common tasks like checking out the GitOps repository in the application, running a Docker build, publishing in Helm, setting chart versions, things like that. And during our release process, we have some GitOps flows for delivering the application to a development staging production environment. So that's really how it works is you just have to set up one of these Argo workflows to invoke some CWFTs. It's all set up for you, nothing really to do. So let's go back to the pipeline and see how we're cooking there. It looks like it's already on its way to production through the release process. Let's take a look at the integration of GitLab with Argo. So you can see that what we're doing here is calling Argo, and when it invokes an Argo workflow, the content that we're looking at here didn't technically run in GitLab Runner. It actually ran in Argo workflows here. I'm going to have to wait to show you that until I have my OIDC merged. But when you're looking at the output here, each one of these jobs, it'll change color every time it switches to a new step in the Argo workflow. And all the output from Argo workflows gets directly sent back to your CI job in GitLab. So from a developer experience standpoint, the developer gets to stay in GitLab. They just submit their pull request. They never have to go to a third-party, Argo workflows user interface. They get to stay right where they're comfortable next to their code. And that integration we have working for all of the different stages of a application delivery. So this is delivering it to the development environment. You can see we have a release candidate here of 6F91C. And if we were to look at the repository commits, you would see that is the most recent commit that got published to the main branch. So we leverage a release candidate branch, a release candidate image name for the container. Through iterations in dev stage, testers find stuff and it's still not ready to go. We stay on the same Helm chart version until the point where you release. Once you go through the release process, if we look at that in the pipeline here, the release process is a little bit different because instead of a release candidate, it actually uses the final version of that Helm chart. So an 0.1.1 version of this application has just been deployed, and you'll get a metaphor development.yourcompany.io. And you can see that while development is on the pre-release version, if we went to production instead, that one is actually on the final released version, 0.1.1. And the CI that we provide you with will automatically go back to the metaphor repository and bump your chart for the next version. So now when we go to the chart that's housed in the application repo, you can see that we're already ready for the next patch of the application. So that's how the CI works in on the Kubefirst platform for a microservice delivering. And I guess a couple other items that we want to call out. So let's log into Vault with, again, we're going to look at the output from the Kubefirst installation process. I'm going to go to my non-hidden version and drop my token in here. And let's take a look at what we have. So like I mentioned a little bit ago, all of the secrets that are throughout the Kubefirst platform are entirely managed in Vault in a very, very simple way. So at the top, we have a secrets engine called Secret, and we also have a secrets backend called Users. So let's look at Secret first. Secret is all the passwords for the infrastructure and applications. That includes Atlantis here. You can see that in order for Atlantis to run, it needs a handful of Terraform variables and provider variables. For Chart Museum, we need access to be able to publish charts. CI secrets, we have some personal access tokens and things of that nature. Our development metaphor application also has a secret 1 and a secret 2. This is obviously not a sensitive secret. It's just for demonstration purposes. But if we were to look, for example, at metaphor development, you'll see this development secret 1 and development secret 2 is being provided to us through the use of these secrets. Now, we don't have metaphor connected directly to Vault. We're using an engine called external secrets operator to pull Vault secrets out of Vault, make them available as native Kubernetes secrets so that they can be ingested by your application. And that removes the real-time dependency that your application has on Vault. So if you ever needed to conduct a Vault operation, you needed to do a complicated upgrade, you were worried that that was going to impact your running applications. No, your applications will continue to use native Kubernetes secrets that are provided through the external secrets operator, but they'll all be sourced and regularly pulled and synced from Vault. And it's some really easy patterns. We'll do some live streams down the road that sort of break down all these neat architectural decisions in depth. Definitely want to dive deeper into Vault with you guys. From an OIDC standpoint, this is how Argo CD and Vault are able to leverage the OIDC backend in GitLab. Yeah, that's really all we have to show about that secret backend. The other secret backend that we have is the user's secret backend. The user's secret backend is only accessible to the root token. So keep that root token that is provided to you. Like that. There we go. So the root token that's provided to you right here in the output from Kubefirst, keep that real close to the vest. That's how you were able to provide your users with their initial logins for all the applications in Kubefirst. So before, when we submitted that pull request against the GitOps repo and had Atlantis running our infrastructure and telling us it was going to create some new users, it creates these users, admin 1, admin 2. Had you changed that pull request to include your team, you would see your team in here with their initial password. So if we were to take a look at this, for example, admin 1, and I'm just going to actually, let me go like this and hit copy. So if I were to log out of GitLab, for example, I could log back in with admin 1 and this password. And now I'm logged into GitLab as an administrator. And similarly, if I were to go to our other applications like Argo CD as an example, I could log out and use this login via GitLab instead. And now once I authorize that admin 1 in GitLab, has access to Argo CD. Now I'm in Argo CD as an administrator as well, and the same story holds for your developers. So it's a really lightweight, frictionless way to get a user to propagate through all of your applications, all leveraging single sign-on. They're now in charge of their own passwords. They can reset them in GitLab, and it propagates throughout the system. So not a lot to set up single sign-on and OIDC throughout the platform for your whole team. Let's see. I think that's everything that we wanted to show during this high-level overview of the Kubefirst platform. Let me get back to my slide. And present to so with all that foundation laid, we wanted to sort of tell you guys where we're going next with Kubefirst. We have some really exciting big functionality pieces that we're going to be adding to the Kubefirst platform. All along, we're really excited to be in a position now where we're a part of KubeShop and building a team around the project. It's been something the project has needed for a really long time. Now that we have that team support, we're really excited to be doubling our Git providers so that we're not just a self-hosted GitLab shop, and we love GitLab, but we know that GitHub is also a very, very popular Git provider. We've already done some great work on an enterprise pilot with running the Kubefirst platform in a GitHub environment. And we're excited to take some of the best lessons learned there and apply them to the open source version of our Kubefirst platform. We have, after that next release, we're going to be adding Crossplane as an infrastructure management mechanism for cluster provisioning operations. In the following release, we're going to be expanding into the GCP cloud so that we have optionality for installation into AWS or GCP. And then once we have that available, we're going to start tackling some larger, more involved operations of multi-cluster, multi-cloud, being able to switch traffic back and forth between a blue and a green production or a AWS and GCP production. And beyond all else, we're looking for feedback from our users as to what a user community would want out of the Kubefirst platform. So please join our Slack workspace, be vocal about the things that you are looking for out of our platform, open an issue, and we will prioritize the things that our user community is looking for out of this platform. So Kelly, I think I'll hand it back over to you.
Awesome. And I will say we got a very nice little comment here from David. Was watching your whole demo and everything. So that kind of wraps everything up, at least for this time. Here's a link to the Kubefirst GitHub page, also available at kubefirst.io. And then we made a quick little link to get to the Kubefirst Slack channel where John and Jared are there, in addition to the other Kubefirst engineers as well. So we'll be doing a couple more live streams coming up in the next couple of weeks, couple of months. Feel free to reach out if you have any questions, and we'll see you on the next one.
Awesome. Thanks, everybody.
Guys. See you later.
See you.